Let's look today at how NVMe Express, NVMe, is ideal for 4 separate modern workloads. Workloads such as containers and virtualization, NoSQL, artificial intelligence, and traditional database. Let's look at containers and VMs. Containers and virtualization today are run on something called Hyper-converged Infrastructure, or HCI. Now what HCI is it takes a set of local servers and combines that into a single local private cloud. Now inside this private cloud, each server is responsible for running hundreds of individual VMs or containers. Now this obviously is going to tax the CPU, it's going to tax the memory, and it's significantly going to tax the storage inside this HCI. The storage today for this HCI is primarily hard drive based. Now hard drives are a great idea and they're great for storing most of your HCI data. But what is recommended by most HCI vendors today and what can really accelerate your workloads is caching, an NVMe Express frontline. By using a small NVMe cache in front of a large hard drive, you're able to get the performance and low latency of NVMe Express and the capacity and price effectiveness of a hard drive setup. So what's great about this is it has out-of-the-box support, meaning that no special drivers are required to enable this sort of caching in most HCI vendors' software today. Now, beyond just pure HCI for standard workloads, if you're doing a business intelligence or a very business-critical database, you can actually move to an all NVMe Express-based setup where, instead of hard drives, you replace those hard drives with NVMe SSDs. And that is able to give you the full performance benefit of up to 6.4 gigabytes a second read of any individual NVMe SSD. High-performance OLTP and OLAP databases are run on bare metal servers today because they need gobs of server CPU, they need gobs of memory, and they need gobs of storage performance. Now, for OLTP type databases, a lot of the performance goes into the log writes. And accelerating those log writes can actually accelerate your database. The fastest and easiest way of doing that is via NVMe. Placing an NVMe drive in for your logs lets you take advantage of NVMe Express's ultra-low latency because it doesn't need a host-based controller, while still allowing you to keep your data on your existing hard drive arrays. Now, for OLAP applications, they have a slightly different workload. They do something called table scans, where they really care about bandwidth. And here, putting NVMe Express for both your log and your data lets you take advantage of NVMe's super high bandwidth of about 6.4 gigabytes a second per single add-in card. Combining both of these types of applications, you have something called complex joins. And this is where the database has to go off and collect data from the entire database to answer a business query. This is a great use case for NVMe Express. NVMe has up to 65,000 queues, which allows the database to send down all of those requests and get them answered much faster. And that gives you a faster time to answer from your database. NoSQL Scaleout shared nothing architecture is ideal for NVMe Express. Because what it lets you do is it lets you place an NVMe SSD in each node of your cluster. That gives you NVMe's up to 6.4 gigabytes of performance in each node. What's also great about that is it's doing this in a very small form factor, an add-in card. To get to that 6.4 gigabytes a second using other techniques or other interfaces, you're looking at many more devices. And that lets you have a much higher density and lower space cluster than you would have otherwise, thanks to NVMe. Now, one of the other issues with NoSQL is a background process called garbage collection. Now, this is a very I/O-intensive process that can affect the performance of your database in the foreground because there's just so much I/O going on. NVMe here comes to the rescue with its up to 65,000 I/O queues, and it's up to 256 individual interrupts to lessen the CPU load and make that background operation stay in the background and not affect your foreground NoSQL performance. Machine learning involves training a neural network by applying millions of input vectors against a set of massively parallel, massively power-hungry, and massively expensive accelerators. In these sorts of architectures, the CPU is only there to shuttle data between the storage and those accelerators. But if the CPU is stuck waiting for data, the accelerators are stuck waiting. This is where NVMe comes in. NVMe, with its direct PCI Express interface, speaks the same language as these accelerators, and it can help minimize the CPU overhead for any sorts of transfer of data. Beyond that, NVMe Express has advanced data transfer features such as scatter-gather lists that help minimize the amount of work a CPU has to do for each of these transfers, keeping the CPU from becoming an AI training bottleneck. So we've seen how NVMe Express, with its direct PCI Express interface, it's low latency because it doesn't require a host controller. It's high bandwidth, enabling very dense server deployments, and its advanced queues, interrupts, and data transfer features can accelerate these workloads. It's just another example of how NVMe Express is the proper choice, really the only choice for modern server workloads today.